Okay, this is the slope and equation of lines, parallel perpendicular equations part. And we always need to have these because we'll have other shapes later on, like squares, rectangles, rhombuses, parallelograms, that will have parallel sides, that will have perpendicular sides, and they'll be on graphs. They will graph a parallelogram and ask you certain features about it, and you need to know by looking at the graph what's going on. So, slope is where we're starting. We're on page 5. Just a few little more terms to fill in. And this is, I don't think I put slope on your notes. So just get to page 5 and wait till you see. I think it starts more with the parallel part and all that, so don't worry about slope just yet. But slope is important. Look at this guy on the lawnmower. You know, he's not considering slope. This is not a trick photography because look at the trees. Trees go straight up and down. So yeah, this old dude needs to check his manufacturer about his lawnmower because that is not the way to do it. All right, parallel lines go in the same direction. You know that. Now, they have symbols in geometry with the little arrows. They can be arrows or they can be little triangles, extra arrows on each end, but they match. The double arrows with a double or a single with a single, those are parallel to each other, those are parallel to each other. So when you see that, you know those are parallel lines. Or if you have the symbol with the names, line K is parallel to M, or line AB is parallel to line CD. So that's an easy one to remember. And we see parallels everywhere we go. But they're also on the same plane. So, let me give you a little example here. I'll show you on the board. You've got your parallels. I'm dropping everything. Parallel lines, here we go. Parallels go in the same direction. But if they're not on the same plane, the same flat surface, you think, oh, parallels just don't touch. But, see that? Yeah. All right, so here they are parallel, but what if I turn it like this? Okay, one's coming out from the board towards you and the other one's still going straight across. Are they touching? No. Will they ever touch? Their lines, they keep on going. No, they're not going to touch. All right, so that's not parallel, obviously. They have to be on the same plane, same flat surface to be parallel. So that's part of the definition, not just go in the same direction, but not just not touching. It's got to have the same plane. Okay? Don't y'all love seeing me in the video? Okay. Alright, moving on here. So examples, we see these in everyday life. Roads, can you parallel park? Okay. Come to Crystal Springs, we got curbs that come up 3 feet high and they'll scrape up your bumper really good. I'm still not very good at parallel parking. I'll drive around to try to avoid it. Alright. Parallels. Okay, next, perpendicular. Now this word, people tend to forget what it means all the time. They make right angles. When they are perpendicular, the word perpendicular means it's going to make a right angle. So that's a number, right? How many degrees is a right angle? 90 degrees. So when you see or hear the word perpendicular, you'll be thinking right angles. Or better yet, when you see that little upside down T, that's the symbol, that's telling you you got lines that are making a 90-degree angle. Okay? They're perpendicular, they're right angle lines. They're going to touch. Now they can touch and make one right angle, or they can make a bunch of them. Like this one, this rare little T shape right here, there's a right angle there, but there's also one right next to it. There's one right here, but there's one vertical, which is opposite to it. There's one right here and one right here. I always think of it when you see the Jesus cross, you get 1, 2, 3, 4 right angles right there. Okay? Okay? All right, so perpendicular lines. Perpendicular lines, 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 per everywhere. We see right angles everywhere, so man-made stuff is always usually made with right angles. Alright, lines can be on a plane. Alright, so see the soccer guys on the plane, they are on the field, they are lined up, but that's a line is on the plane. It's flat on it. Okay? Now, when you draw a plane, remember it's just a big old parallelogram. If I draw a line that's supposed to go on forever and ever, the plane also goes on forever and ever and ever. It's not just this little cute parallelogram. It is this huge sheet of paper that covers the whole entire universe. Okay, so it's going to go on too. So, when you see the solid line like this is solid, it's not dashed, then that means it is on it. Just like those soccer players were standing on the field, that is laying flat on the plane. Is X hanging off the edge? What do you think? No, there is no edge. I just told you the plane goes on forever, the line goes on forever, so there's no edge to hang off of. Sometimes they'll draw it like an edge, but there's no edge, it's not hanging off. It's a solid line. Alright, and Y is on it as well, so both points. The variation of this is when something is passing through. So passing through is going to be drawn like this, but what it means, let me get out my little demo here. What it means is that you have your plane, big flat plane here, it's red, alright, remember it keeps on going. But what's happening to this line? It is passing through the plane. So, is there part of the line, my stick, that you can't see? Yeah, you can't see my hand holding it back there. So, this part that's back here behind there, that's what the dotted is on the drawing. So, when you see the dotted line, it's supposed to be passing through that flat surface. This could be the front of a rectangle. This could be just a solid plane and it's a flat surface, so it's passing through. It's a 3D kind of effect to it when you do that. So, here's my questions for you. Is X on the plane? Think about it. Where is X? X is where it's solid. Right here, stops right there at X. And then comes out the back. Dotted line. So that's where it goes in. Yes, X is right there in that spot where it went in. So yes, X is on the plane. What about the Y? Is Y on the plane? Now, if you just think about it being flat on it, then yeah, it would be on it. But it's not flat, is it? It's standing out. Where is the Y? If this is X right here, Y is going to be somewhere out here where my hand is now, right? Here's X, here's Y out here. So is Y on that plane, on that flat red paper? No, it's up above it right there. So, a little 3D effect that you got to get straight in your mind. So, X is yes is on it, Y would be no on it. Okay. And then skew lines are not on the plane at all. So a skew would be like what I showed you the other day, today, where they're not parallel but they're not touching. The sideline and the goal post, are they ever going to touch? That post sticking up? No. The sideline does not touch the goal post, but they're not parallel. So that's called skew. Alright? Now, if I took those, let's see, that drawing with the plane, and here's a line, and here's a line, line A, well, not line A, let's do it like this, A, B, X, let's put Y right here, Y. Okay. All right, so A and B, line AB, line XY. Are they parallel? What do you think? No, because AB is flat on the plane and XY is passing through. So if this one's flat on the paper and this one's sticking up out of the paper, it cannot be parallel. They're not going the same direction and they're not on the same plane, not on the same plane. All right, is A on the plane? Yes. Is B on the plane? See the dot for B? B is still on it. The solid line is on the plane. All right. Is X on the plane? Yes. X is where it went into the hole and came out the back. See the dot, dot, dot? If that's where it is right there, that spot where it goes in, then yes, that is on the plane. What about Y? Y is not. Y is sticking up above X, up in the air, not on it. Okay, so next, the slope of the line. Now, slope. Now, you can probably figure out just by looking at these houses. Some of these are in the north, some of these are in the south. Northern people can't have roofs like this. Okay, they have to have them a lot steeper. Why do you think that happens? Because of snow. Okay, snow comes along. Snow comes along and builds up on top of their roof. Boom, 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 boom. Snow is water, right? Water is heavy. The more snow that gets packed up there, the more it's pressing down on your plywood back roof, okay? You got shingles, but underneath there is just a bunch of plywood. So theirs is steeper. What's going to happen eventually? It's going to get heavy. It's going to roll off, fall down. That's what they want it to do. Sometimes they have big scrapers, and they'll kind of get out there and scrape a little bit, make it fall. Sometimes they'll come out the door, slam the door hard, and it'll all fall. So you have to be careful. All right, but us, okay, we don't get a lot of snow. But if we did, all that snow up here would just sit and pack down, and you'd be like the guy on Mayhem, and he'd be like crushing your roof in because it'd be too much weight. If it ever does have a big snow, starts building up, get out there with a stick, try to knock some of it down. Sometimes it'll slide, sometimes you'll have to get up there, not get up there, but maybe get up there with a ladder or something. Hit it with a stick and make it come on down so it won't crush your roof. Alright, so slope is important. Slope is the steepness of a line. It's talking about the vertical change compared to the horizontal change. The vertical change, remember from algebra, is the rise. The horizontal change is called the run. Now in math, we write it as a fraction, rise over run. When you deal with everyday problems in construction, anybody ever go into a building kind of situation for your job, you use decimals. Road work, people making new roads and stuff, engineers, they use decimals for their slope. Alright, so if you read the line going left to right, just like you read a word. If I wrote Papizan up here, you would start at the P and go to the right. So just like you read words, you read the line. So if I put this line on here, it's going uphill or downhill. If you're going that direction to the right, like a word, it's going up. Okay? It's going up. That's a positive slope. Whatever kind of slope it is positive. Alright. Whatever. And just the opposite, still going to the right, it's going downhill, so that's a negative slope. If it's horizontal, then that is 0. Now 0 is a number. 0, you got 0, and then 1, 2, 3, and then you got -1, -2. So it's a spot in between your negatives and positives. So it's just flat 0. No problem, no hill ahead. So you're just driving straight. It is the number 0. But a vertical line has no slope. No slope means when you do your rise, it's rising, right? It's going up and down. Let's say it went up 8 spaces. How much is it running sideways? 0. You cannot have 0 on the bottom of a fraction ever, ever, ever. That's like saying I've got 8 pieces of nothing. If there's 0 pizzas, okay, you always do the part over the whole when you think about a fraction. There's 0 pizzas, but you're going to have 8 pieces. No, that can't happen. Now, if there's a 0 on top, if there's 8 pieces of pizza, or 8 pizzas, and I give you 0, you know, that could happen, right? You don't want that to happen. But your part will be 0, and that's just what it is. You've got 0. But this is not a number. This is an undefined number, and so they call it no slope or undefined because it does not exist. You can't have 0 parts of something that isn't there. Okay? You can't have parts of something that isn't there. So the up and down line is thinking, you know, the way to easy to remember it. Would you drive on that? No. What's going to happen? Cool, huh? Sound effects. All right. So quick little quiz time. Nothing. Just think of it as we go. What kind of slope? Positive, negative, 0, undefined. What is it? Positive. All right. What's that? Negative. 2. Going to. Remember, it doesn't matter if it's a line with arrows on both ends. You're always reading it going to the right. So if I'm going this way, that's going downhill. Negative slope. All right. Still negative. Okay. Like that. Positive. That's the, which one? 0. 0 slope. Okay. That one is what? Positive or negative? Going to the right. So here's the left end. Here's more right. That'd be going down. So that's negative. And that's undefined or no slope. You can write either one. Okay. So when you get it on the graph, you get to count it. That's just wonderful because you don't have to do any kind of like algebra stuff. You look at the line and decide, is it positive or negative? That's just what we just did on that last screen. You decided, was it positive or negative? And you just write it down. Then you locate 2 points that are on 2 intersections, you know, lines. You know, you don't want to pick one that's like in an empty space. You want to get one that's at a corner, you know, something like that, and not just one that's up in the middle. All right, count the spaces with your rise and your run. You've already decided if it was positive or negative, so you don't have to worry, am I going up or down or what? You just count rise and run from point to point. So here's an example, and I want you to practice these as we do. So positive or negative, just look at it. Negative, so we already know this is a negative slope. Then look at the graph, and I can't blow it up on here, but it's going down. Do your rise and your run, draw it on there. And so that's going to go down 1 and over 1, 2, 3. Count your spaces. Remember, it was negative. Count your spaces, not the lines. So from point 1, 2, 3 spaces, and then 1 space coming down. Rise over run. And it was negative. And we said that to begin with. Okay? All right, positive or negative? Positive. Now let's count or draw it. Go up 2 and over 5. So that's 2 over 5. Okay, what sign? Positive or negative? Negative. So you just get that out of the way first and then connect. Now, this time we got a negative 2 over 2. Can it be reduced? Yeah, so reduce it, and that'll be 1 to 1 or just negative 1. You can leave it like that, or you can leave it like that. Okay, just make sure you put the negative. All right, what about that? What was supposed to happen? All right, it does have a rise of 2, but hold on. Okay, so it has a rise of 2. Okay, but how much is it running? 0. So what happens when 0 is the bottom? You can't do that. That's a no slope or undefined. No definition for that number. Alright. Now what if you had 3? It is a positive slope. You can pick any 2 points. Now you can pick the 2 that are furthest away, but that's going to be a lot more counting if you do it like that. If you do 2 that are close to each other, it's not so bad. So 1, 2, 3, 4, 1, 2. So that's a positive 4 over 2, and yes, that reduces to 2 over 1 or just 2. All right, and of course that's going to be your 0. You should know it right off the bat. 0 slope. Okay. What if there's no graph to look at? Then you got to do the formula, okay? Hopefully back in algebra you were taught that little formula. Sometimes I'll give it to you on the ACT, but it's just subtracting the y's. Remember how we did with midpoint? We added them. Well, when you do slope, you want to know how much did it change the distance between, not the distance, but the difference in the space between them. Like, did it go 2 spaces up or whatever? So it'll be subtracting the y's over the x's. Still rise over run. So you do like that. Anybody know what those little triangles mean? Delta is the Greek letter, okay, of y. Delta of y means the change of y. So the change of y over the change of the x's. And so you do subtract. Alright, and you get 2 points from the line. Another little extra credit to look up. Y is M, used for the symbol of slope. See right here, the M is used for slope. That's your like with the formula. So it's a word. It's a French word. You can look it up and turn that in to a little extra credit. Send me a text or something. All right, and you can practice with it. We're not going to do that. All right. So Grandma needs her wheelchair ramp to be fixed. Grandma needs her wheelchair ramp fixed, and you've already got one built, but you want to make sure it's in the right codes. If you ever have your own business and you have a wheelchair ramp out there, which most people do for the parking, it has to meet a certain code, which is 1 inch in height for every 12 inches in length. That's the rise and the run. So it only can go up 1 inch in height for every 12 inches in length. Now, at Grandma's house, the front door, she's in one of those old houses with the porch on the front. It has big steps that you climb up, and it's 82 inches high. So you made the ramp for her steps up there, the ramp going up to it, you made it a length of, not the actual ramp itself, but on the ground, it comes out for 124 inches. So let's check and see, is your ramp within the building code? Now, to change this over so we don't have to fill with fractions, let's divide it and make it into a decimal. So, 1 divided by 12 is 0.083. Repeating, okay? So we don't want it any higher than that, because higher than that, it'll mess her, it'll be too fast. So we have a rise of 82 inches, and we have a run of 124 inches. So we just divide that on the calculator. Like I said, people in business, they use the decimals, and it's so much easier to compare. So you get 0.661. So look at that compared to that. Is your ramp, her old ramp for her house, higher than the 80.083? Yeah, it's like 6 times higher. So that is not good, and you need to tear that down and fix it so that you don't have. All right. So equations of a line. This is a longer lesson, I know. Equations of a line. Remember the y equals mx plus b. Standard way to put a line in the calculator. Easy, easy. But remember what the parts stand for. Okay, so we're looking at the equation of a line. Remember, m is the slope. B is your y-intercept. So like, here's your graph, and your line cuts across it. Y-axis is right there, so where is your y-intercept? Where does it touch the y? right there. That's what the B part is, right there, that point. So, when you look at an equation that is set up with y by itself, then that's called the slope-intercept form, and that way you can pick out, here's my slope, here's my y-intercept. Alright, so on the second one, the slope will be next to the x, -1, you don't see a number, right? And the b will be -4. And then down here, slope would be 3/2. And it's okay as a fraction because that's slope, rise over run, right? And then the intercept would be -2. Alright, so what's the intercept here? Kind of hard to see. What would it like? 1, 2, 3. Okay, +3. This would be at -1. The intercept, that's all I'm looking at. Where is it crossing? And right there at 0. Alright, so if you're given a line on a graph, you should be able to write the equation. You're going to have 2 points marked on there. And you can use your equation. What's the intercept? Remember what we just did. So that would be 1, +1. What is the slope? What's the rise and the run? And, you know, you get on here and count it. Just like we've been doing. 1, 2, 3. 1, 2, 3, 4. 3 over 4. So, take your equation, y equals mx plus b, and plug in the m and plug in the b. And that's your whole equation. That's all you're writing. It's like a formula for that line. Okay? So let's try it. Oops. Skip that one. Alright, so the intercept here is 3. The slope +4/2, which will reduce to 2, +2. So it will be y equals 2x plus 3. Alright, intercept 1, 2, 3, 4, 5, 6, +6. Slope 1, 2, 3, 1, 2, 3. +3. Oh, not positive, it's negative. Downhill, don't forget that. 3/3 or -1, that reduces. So y equals -1x, or just -x, plus 6. So, 0, I'll find that up here. Intercept is 0, and that can happen. And then your rise, 1, 2, 3, 4. So slope 4/2, or just 2. So y equals 2 times x plus, if this 0 plus 0, sometimes they'll leave it off and it'll just y equals 2x. So that's probably how they'll write it. Alright, so what do you do if it is right here? Well, I can't draw it straight. Let's say right there. There's our line right there going up and down. Now, you can do, it's an undefined, but it does still have an equation. So think about this. Which line is it hitting? Is it hitting the x-axis or is it hitting the y-axis? It's hitting x, it's not going to touch y. So if it doesn't touch y, it's not going to have a y in it. You're not going to start with y equals. This is x equals 3. Every point on there has x equal to 3, and so that's the equation of that line. So if you have one going the other way, what's it hitting now? It's hitting y. Where is it hitting y? At the 1. And so even though it seems like it would say it'd be an x line going sideways, it's not touching x. You have to think of it as y equals 1. Alright, so now I'm going to give you the equation. I want you to draw it. So pull out your slope, that's easy to see, 2. You can make it a fraction over 1, and then your intercept is just that 1 that's out there by itself. So for steps, let's see, plot the B, okay, put the 1 on there, on the y-axis, right there, see that blue dot? And then do your slope as a fraction, 2 over 1. So this is telling you where to go from that first point. The 1 was your intercept, start there, and then go rise 2, run 1. So up 2 and over 1. Okay? And draw your line. Do it about 3 times and make your line go through there. Okay? Same thing. The intercept, -4. That's your B part. Okay? And now the slope is going to be a -1. So make it a fraction over 1. Now I will leave the negative part. If it has a negative, leave the negative up top. So that'll be down 1 and then to the right. When you get through, it should be going downhill, right? Down 1 and to the right. Okay, make the run always go to the right. Down 1 to the right. And draw it out. A lot of this is not on notes, just practice. But you get to practice it on the worksheet. That was 1. Remember how we said it was +0? So that'd be at 0, up 3, over 1. Something like that. Sort of. And then what would it look like if it was there? Y equals 4. Where's Y equals 1? Right here. So that's going to be a line going this way. Okay? And the x equals -4. That'd be over here. Alright, so what if y is not by itself? And you want to graph it? Just get y by itself. Move things away from the y. Move the 2x. You can't put it with the 12, but it can be on that same side. Okay? You can't subtract these. They're just on the same side. Now divide after 3. Every term gets divided by 3. So 3 cancels. That'll make 4. That'll be a fraction. But that's okay. The fraction next to x is your slope. So our intercept by itself is 4. And our slope would be -2/3. And then you go graph it. Parallel lines have the same slope. So this is on the notes a little bit. If you've got parallel lines, like that first one, this is at the negative, the bottom line has that formula. The other one has this formula. What do they have in common? Right here. Slope, slope. They have the exact same slope. So if you have that, every time you've got that, you're going to have parallels. Okay? Perpendiculars have different slopes. The first one has this equation. The second one has this. They're almost like parallels, but they're perpendicular. They're going to hit at right angles. So that means squares and rectangles will have slopes like this. One of them, the slope, is 3 over 1. This one has a -1 over 3. So they're sort of opposite. You change the sign and flip it over for it to be perpendicular. Now, if you just change the sign, it was 3 over 1, and you make it -3 over 1, no, that's not going to work. Or if you just flip it, 1 over 3, but you don't change the sign, that's not going to work. It'll be a line, it'll be all kinds of lines that can go through here, but it won't be perpendicular making a right angle, so we wouldn't know about the rectangle or square having that. So just know